Right now, somewhere in the world, a fire is burning that nobody planned for, and in the next few seconds, it will double in size. We have been running toward fire with whatever we could carry for over 2,000 years. Clay pots, leather buckets, bronze syringes, doing everything we could and still watching entire cities burn to the ground. Every single era of human civilization has had to solve the same problem, and every single era has gotten a little bit closer. This is that story. 2,000 years of disaster, invention, and the quiet revolution happening right above your head every time you walk into a building. That thing on the ceiling that you've never once thought about, it might just be the most important piece of engineering you have never noticed. And it took us 2,000 years to build it. So we're going to start in Rome, around 6 BC, and the thing you need to picture is just how terrifying fire was in an ancient city. These weren't buildings with proper gaps between them, they were packed together, timber on timber, often sharing walls. One spark, and the whole block could go. Emperor Augustus understood this better than anyone. He'd watched parts of his city burn repeatedly, and he was done with it. So he did something that no one had done before. He created a permanent, professional fire brigade. 7,000 men, called the vigiles, whose entire job was to walk the streets at night, looking for fires. Now, their equipment by our standards was pretty basic. They had bronze hand pumps, bucket chains, and this thing called a fire squirt. Essentially, a very large syringe that one person could aim and fire at a blaze. It wasn't going to stop a major inferno, but it could knock back a small fire before it spread. And other civilizations were solving the same problem in different ways. In China, they'd figured out that wet matting could smother a fire at its base. In Egypt, they went even more aggressive. If a fire broke out, they'd literally demolish the buildings in its path, knock them down before the fire could reach them. Brutal, but effective. No fuel, no fire. The common thread through all of it is the same principle we still use today. Get there quickly, work together, and cut off the fire's food supply. They were working with clay pots and rope, but the logic was already right. The problem, though, and this is the problem that would haunt firefighting for the next 1,800 years, is that every single one of these approaches required a fire to already be burning before anyone could do anything. You waited, then you reacted, and by the time you got there, it was often already too late. Which brings us to 1666, London, and one of the most catastrophic fires in recorded history. It started in a bakery on Pudding Lane on the 2nd of September, which sounds almost comically mundane for something that would reshape how cities are built. But within 4 days, it had consumed over 13,000 homes, 87 churches, and left something like 70,000 people with nowhere to live. Most of the medieval city just gone. Now, you'd think a disaster on that scale would immediately produce massive reform, but actually, the most important thing that came out of the Great Fire of London wasn't a law or a fire brigade. It was an industry. See, the fire created the modern insurance market, and the people offering that protection quickly realized they had a very direct financial interest in not having the buildings they'd insured burn down. So they set up their own private fire brigades. And here's the bit that always gets people. If your house was insured, they'd attach a small metal plaque to your front wall with their mark on it. If fire broke out, their brigade would rush over, check for the plaque, and fight the fire. If you didn't have the right plaque, they'd stand there and watch it burn. Look, it's a bit grim, but it worked. Competition between these companies pushed them to build better equipment, hire better people, get there faster. Fire protection improved more in the century after the Great Fire than it had in the 1,000 years before it. The 1700s were when firefighting got its first real mechanical upgrade, and the breakthrough that made everything else possible wasn't actually the pump, it was the hose. A Dutch inventor named Jan van der Heyden had this insight in the late 1600s that sounds simple in retrospect. If you could make a flexible pipe that you could steer toward a fire, you'd be so much more effective than a rigid metal tube. So he developed a leather fire hose, stitched and riveted sections of cowhide that could bend around corners and reach places no pipe ever could. By 1725, an English engineer named Richard Newsham had built what became the gold standard hand-pump fire engine, a wheeled machine that 4 to 8 people could operate together to deliver a continuous pressurized stream. Before this, you were always throwing water in discrete bucket loads. A continuous stream sounds modest, but it was genuinely revolutionary. Then came steam in the 1830s, and this is where firefighting starts to look genuinely powerful. A steam-powered pump could move so much more water than any number of people could. Fires that used to spread across whole city blocks could now often be stopped at a single building. But here's the thing. For all this progress, nothing had fundamentally changed about the basic approach. Something caught fire. You heard about it. You rushed there. You tried to put it out. The gap between when a fire started and when anyone could respond was still minutes, sometimes much longer. And in those minutes, everything could be lost. What came next would change that completely. And it came, of all places, from a piano factory in Connecticut. Henry Parmalee was not a professional firefighter or an engineer. He made pianos. But in 1874, he came up with an idea that was so elegant, it's almost annoying how obvious it seems once you hear it. He ran water-filled iron pipes across the ceiling of his factory. At intervals along each pipe, he put small holes, each one sealed with a plug held in place by solder, a metal alloy that melts at a specific temperature. The idea was this. If a fire breaks out underneath one of these holes, the heat rises, reaches that solder joint, melts it, and the plug falls away. Water floods out, right onto the fire, right where it's needed. And crucially, only the heads directly above the fire activate. The rest of the ceiling stays dry. He installed it in his piano factory, and it worked exactly as he'd designed. No fire brigade needed, no alarm to wait for. The building took care of itself. A few years later, Frederick Grinnell took Parmalee's concept and refined it into something even more reliable. His 1881 sprinkler head design became the industry standard, and I mean genuinely the standard. Versions of the Grinnell head are still installed in buildings today, 140 years on. That's remarkable longevity for any piece of technology. Insurance companies immediately understood what this meant. If your building had sprinklers, the chance of a catastrophic loss was dramatically reduced. So they offered significant premium discounts to buildings that installed them. The economic incentive was real, and sprinklers spread rapidly through factories and warehouses across the US and Britain. But, and this is the frustrating bit, they were still mostly in industrial buildings. Schools, offices, garment factories, tenements, mostly nothing. And it took a tragedy of almost unbearable proportions to change that. The 25th of March, 1911. It's late afternoon in Manhattan, and on the upper floors of a 10-story building on Washington Place, several hundred workers are finishing their shift at the Triangle Shirtwaist Factory. Mostly young women, mostly recent immigrants, most of them in their teens and 20s. A fire starts on the 8th floor. No one is entirely sure how, but what happens next is a sequence of decisions made long before that day that turned a serious fire into a catastrophe. There were no sprinklers. The factory owner had decided they weren't worth the cost. Some of the exit doors had been locked. Management didn't trust the workers not to steal fabric on their way out. And the fire escapes, when they were actually reachable, were narrow, rusted, and buckled under the weight of people trying to flee. 146 people died in less than 15 minutes. Many of them were found in stairwells. Some had jumped. The public response was something that's hard to describe. Hundreds of thousands of people marched through New York in the weeks that followed. Politicians who had previously blocked fire safety legislation found themselves completely unable to hold that position. Within 2 years, New York State had passed a comprehensive set of factory safety laws that became a template for the rest of the country. It's one of the most painful patterns in the history of safety regulation, that it so often takes something terrible to make people act on risks they already knew existed. The sprinkler had been available for 40 years before the Triangle Fire, but it took those 146 deaths to make it the law. By the time we get to the mid-20th century, sprinklers are well established in most commercial buildings. But the world is changing, and fire is changing with it. New materials, new industries, new problems that water simply can't solve. Think about an early computer room in the 1960s. You've got millions of dollars of mainframe equipment packed into a single space. A fire breaks out. You can't flood that room with water. You'd destroy everything the fire didn't. So, engineers turn to carbon dioxide. CO2 can blanket a space and displace the oxygen a fire needs to burn without leaving any residue. The machines survive. Problem solved. Then there was aviation. Jet fuel burns in a way that's completely different to a building fire. It spreads fast, it floats on water, and a conventional hose does almost nothing useful against it. The answer was foam. AFFF, aqueous film-forming foam, could blanket a fuel spill in seconds, sealing off the oxygen supply before the whole thing ignited. It became standard at airports around the world. And then there was halon. This is the one that's genuinely fascinating. Halon gas didn't smother the fire or cool it down. It actually interrupted the chemical chain reaction of combustion at a molecular level. It stopped fire from being chemically possible in the space it occupied. It was extraordinarily effective. The military loved it. Data centers used it everywhere. There was just one problem, and it was a big one. Halon was tearing a hole in the ozone layer. When this became clear in the 1980s, the Montreal Protocol of 1987 was signed by virtually every country on Earth, committing to phasing out ozone-depleting substances, including halon. Overnight, the fire suppression industry lost its best tool and had to find something else. What came next were the clean agents. FM200, Novec 1230, inert gas blends. They work differently from halon, but they don't damage the atmosphere. It took real engineering effort to get there, but within a decade, the industry had largely made the transition. It's a genuinely good news story, which are rarer than you'd think in the history of fire suppression. I want to take a step back here and talk about something that gets less attention than suppression, but is honestly just as important. Detection. Because a sprinkler or a CO2 system can only help you if it knows there's a fire to respond to. The first automatic heat detector was built in 1890 by Francis Upton, one of Thomas Edison's own engineers. His device used a bimetallic strip, two different metals bonded together, that would physically bend when it got hot enough, closing an electrical circuit and triggering an alarm. Simple, reliable, a genuine step forward. Smoke detectors took longer. The ionization smoke detector, the type that uses a tiny amount of a radioactive material called americium-241, wasn't developed until the 1960s. What it does is create a small electrical current inside a chamber, and when smoke drifts in and disrupts that current, the alarm goes off. They're very good at catching fast flaming fires. Photoelectric detectors work differently. They send a beam of light inside the sensing chamber, and smoke particles scatter that light in a way that triggers the alarm. They're generally better at catching slow, smoldering fires, the kind that might burn for hours in a wall cavity before anyone smells anything. Today's smart detectors do both, and they connect to your phone, to your building management system, to emergency services. They're cheaper than they've ever been, and more capable than they've ever been. And here's the thing that I find genuinely troubling about all of this. The majority of people who die in house fires in developed countries die in homes without working smoke alarms. Not without expensive sprinkler systems, without a $20 battery-powered alarm. The technology has been available for 60 years. It's not a knowledge problem, it's not a cost problem, people just don't do it. So where does all of this leave us today? Because the honest answer is that modern fire protection systems are so sophisticated compared to anything that came before, that they almost belong in a different category entirely. Take a modern high-rise building. When a fire alarm activates, the building doesn't just make noise, it executes a choreographed response. Every elevator automatically descends to the ground floor. No one gets trapped in a lift. Fans in every stairwell pressurize the air so smoke can't flow in. Dampers in the air conditioning ducts slam shut. Sprinklers activate, but only on the floor where the alarm tripped, not everywhere. The whole thing happens in seconds, automatically, without anyone having to make a single decision. And now AI is starting to change the detection side in ways that are genuinely new. Machine learning systems can monitor thousands of building sensors simultaneously and notice patterns that a human operator would never catch. A gradual heat rise in an electrical cabinet over 3 hours, or a sensor reading that's just slightly out of its normal range. They can flag risk before there's any visible sign of fire. That's a fundamental shift from everything that came before. Drones are being trialed for reconnaissance inside burning buildings, flying into spaces that are too dangerous for firefighters, mapping fire spread in real time with thermal cameras, locating survivors. It's early days, but the potential is significant. Water mist systems, which produce droplets so fine they essentially create a fog, are being used in heritage buildings, ships and tunnels where traditional sprinklers would cause water damage almost as serious as the fire itself. The droplets are small enough to float in the air around a flame, absorbing heat and displacing oxygen without flooding everything. And in wildfire management, satellite systems and AI models are now being used to predict how a fire will spread, hours before it gets there. The idea that you could know where a wildfire is going before it goes there and position resources accordingly, we're not fully there yet, but we're getting close. So, 2,000 years, from Augustus and his vigiles patrolling the streets of Rome with bronze syringes and clay pots, to smart systems monitoring every corner of a modern skyscraper without a single human having to check a thing. That's quite a journey. And looking back across all of it, there's a pattern that keeps repeating. Progress almost always comes from one of two places. Either someone brilliant gets sufficiently obsessed with a problem and works it out, Parmelee and his piano factory, Grinnell and his precision engineering. Or something so awful happens that society simply can't justify doing nothing anymore. The Great Fire of London, the Triangle Shirtwaist Factory. Disaster after disaster, forcing change that common sense should have driven years earlier. The numbers we have now are really quite extraordinary. A building with an automatic sprinkler system is about 85% less likely to have a fire death than one without. Property damage is reduced by more than 60%. These aren't estimates or projections. This is a century and a half of data from real fires in real buildings. And yet, in most countries, you can build a house, the place where most people spend most of their lives, without putting a single sprinkler head in it. We know what works. We've known for 140 years, and we still don't always do it. I think that's the thing I keep coming back to with this history. The technology is rarely the hard part. The hard part is getting people to use it before something terrible makes them. Fire itself hasn't changed. It needs the same three things it always has: heat, fuel, oxygen. Take away any one of them and it stops. We've always known that. What we've built over 2,000 years is a gradually improving set of ways to get in there faster, hit harder, and increasingly not give fire the chance to start in the first place. That quiet pipe in the ceiling of every building you walk into, that's the whole story, right there.